Hi everyone. So for today's lecture, we're going to start section 10.3 from our unit on the moles. And so we're going to start talking about chemical formulas and how we determine what those values are. So a way to do it sort of empirically through experiments. Okay, so before we get started on that, I just want everybody to review a few things. So make sure you can convert between moles and atoms, or moles and molecules. Make sure you can convert between moles and grams. All right. Make sure you understand how to convert between number of molecules and grams. And then how do you convert liters to moles? So basically go back to that mole map and make sure you understand how to do that. I did post a whiteboard video that went through a couple of the questions on your quiz. So if you're having trouble with some of those, look at that and it should help you out. Okay. So in the meantime, and here's that mole map. So what I pointed out on the video was simply make sure you realize what you're starting with and then figure out how to get to what you want. So if you start with volume of gas, right, you're going to convert from volume of gas using this figure to mole, and then mole, let's say you wanted to go to mass, so grams, you would use this conversion factor. Okay. All right, so what we want to start today is thinking about chemical formulas. So the first piece of this, which we're going to address in this video, is percent composition. So all we're talking about is the percent by mass of each element in a compound. And this will be helpful if you just remember how to do percents, first of all. So remember, a percent is how much the part divided by the whole is times 100. So, you know, if you wanted to know what 25 out of 50 was, all right, well, 25 divided by 50 times 100. Okay? All right. So here's the formula that we're going to use. And we're going to start out thinking about how to determine percent composition from mass data. So the percent composition by mass is simply the mass of the element, usually so mass in grams, over the mass of the compound. So this is the part to the whole times 100. Okay? All right, so let's look at some examples. And what I suggest is, as we go through these examples, I would write them down in your notebook, and you can pause the video at places and really make sure you understand where I'm getting the numbers from, because that'll help when you do your practice problems. Okay, so let's start with a problem that says analysis shows that 2.56 grams of iron reacts with 1.08 grams of oxygen. Okay, and so we can add those two together and we can figure out that the total mass of iron and oxygen is 3.64. Okay, so now remember the mass of the element over the mass of the compound. So the percent of iron is going to be 2.56, right, divided by the total 3.64 times 100, and you should get 70.33%. All right, if we're looking at percent of oxygen, now we're going to go up and pick up, this is the grams of oxygen, divided by the mass of the compound, which is 3.64, times 100, and you get 29.67. All right, and one thing I want you to always do here with these problems is double check yourself. So when we're talking about percent composition, the total has to equal 100%. So once you get your answers, ask if they make sense. And one check of that is, do they add up to 100? And in this case, they do. Sometimes you'll get like 100.01 or 99.99, but you want it to be pretty close to 100. Okay, makes sense? All right, so that's how you get, if you're given the grams of each, how you get the percent composition. All right, but we can also work the other way. So we could determine the masses if we're given the percent composition. Okay, so here's an example of that. If you have 10 grams of a sample of an alloy, so this is the total, right, that is composed of aluminum and zinc. And we know that this alloy is 36% aluminum by mass. So we now want to figure out what are the masses of aluminum and zinc in this 10-gram sample. Okay, so here's where I want you to pause the video for a second, Think about this equation and see if you can come up with the answer. Okay, so hopefully you were doing that. So let's do this piece by piece. So the two things we have to work with here, if it's 36% aluminum, then we know the other 64% must be zinc. So we just subtract the 36% from 100, and now we have the percents of both of our elements. Okay, and then we also know that the total is 10 grams. So if aluminum, for instance, is 36%, we want to know what is 36% of 10 grams. Okay, and so you do that simply by multiplying. So you multiply 10 grams times 0.36 and you get 3.6 grams aluminum. And then you multiply 10 grams by 0.64 and get 6.4 grams zinc. And here again, you can double check. We know our total is 10, and yes, we come up with a total of 10. Okay, so those are two straightforward problems. You're given grams, you figure out percent composition. You're given percent composition, you figure out grams. Okay, you can also determine percent composition if you're given a chemical formula. Okay, and what you have to know here is you're going to look at the formula and figure out how many of each element you have, and then use the molar mass to figure out what percent that's going to be. So let's see how that works. All right, so we're going to determine the percent composition of each of the elements in sodium hydroxide. Okay, so we've got 1 sodium, 1 oxygen, and 1 hydrogen. All right, so step 1 is we're going to determine the molar mass of each element and the final compound. So remember, we need mass of the element over mass of the compound. So here's each of the molar masses. And then if we add them up, we get the molar mass of NaOH, which is 40.01 grams per mole. So these are all grams per mole. So let's just assume we have 1 mole, and then we get the number of grams we would have in each of those cases. So now, and here's a good place to pause the video, see if you can figure out the percent by mass of each of those elements given the grams we just worked out. All right, and so here's our solution. So sodium, we've got 23 over 40.01 times 100, right? Oxygen, 16 over 40.01 times 100. Hydrogen, same thing, right? Now we take our percents and we're going to make sure they make sense. So we're always going to double check, and sure enough, I get 100.01%. So that makes me feel like, okay, I have a good chance of being correct. All right, so that's not very hard. You just need to break it down, keep these samples in front of you, and now let's see if you can do some practice problems. So this is your homework or classwork for today. So go back to the examples of each of these and see how you do on these problems. Okay, so do the best you can, submit them, and then we'll go over them. All right, so hopefully that wasn't too bad, and have a great day. Bye.